Hey guys, so today we're talking about divisible characteristics. Divisible characteristics will help us on deciding if a number can be divided by a certain number, and will also help us on prime factorization. So let's start with 2. For 2, it's really easy. If a number can be divided by 2, which means it's just an odd even number, because it's just the definition of it. And for 2, we just need to look at the last digit of a number, no matter how many digits it have. If the last digit is 0, 2, 4, 6, which is the ones digits of the number, then the number n, which is the number we look at it, is divisible by 2. Now let's talk about 3. 3 is a special one. It's not really a special, but like a unique one. It's the sum of the digits. See if we can divide it by 3, which I don't know why this makes sense. So for example, let's say 123. So each digit will be 1, 2, and 3. And then we'll calculate the sum of it, which is 1 plus 2 plus 3 equals 6. And then 6 divided by 3 equals 2. Let's have another example. 1234. So the digit will be 1 plus 2 plus 3 plus 4, which equals 10. And 10 divided by 3 equals 3 with a remainder of 1. So the remainder will also be 1. So the remainder of a number divided by 3, just the remainder of the sum of the digit divided by 3. And now let's talk about 5. So 5 is also just to look at the last digits, since 5 times 2 equals 10. So no matter what digits, except for the ones digits, it will always be divisible by 5. And then if the last digit is 0 or 5, then the number is divisible by 5. So let's have an example again. Let's say 1230. The ones digit, which is the last digit, is 0. So 1230 was divisible by 5, which is pretty simple. Now, what about if we want to know the remainder? It's also of a number divide by 5, which is also pretty easy. Just for example, let's say 1346, the ones digit was 6, and 6 divided by 5 would equals 0 with a remainder of 1. So the remainder of 1346 is 1. And then 9 is also the sum of the digits divided by 9. And then you can find the remainder of it where it's divisible, which is also doesn't make sense for me, like how this works. For example, let's say 1, 3, 4, or 5, 6. So 13,456. So the sum of the digits will be hold on, this is another good example. Let's say 12,453. Okay, I think this is better. So 124,533, and then the sum of the digits will be 1 plus 2 plus 4 plus 5 plus 3 plus 3, which equals 18. And 18 divided by 9 equals 2, with a no remainder, which means the number is divisible by 9. So 124,533 is divisible by 9, which we just need to look at the digits without calculating at all, which is really good, really nice. Now let's have another example, which is 1,456. And still we're calculating the sum of the digit first, which is 1 plus 4 plus 5 plus 6, which equals 16. And so now we need to divide 16 by 9, which equals 1 with a remainder of 7. So when 1,456 is divided by 9, the remainder of it is 7. Now let's look like kind of difficult one, 11, and it's kind of confused. So for 11, we're trying to see the difference between the odd digits and the even digits. So what does that mean? It's not mean like the number of the digits is odd or even. It doesn't mean that. It means the ones digits and the hundred. For example, it means the ones digit and the hundred digit, and then going on the sum of that digits and the tens digit and thousand digits. So it sounds kind of confusing. So let's have an example. Let's say 12,321. So we need to make the digits, so we're ones by digits. So let's so let me use red arrows as the odd digits and then blue arrows as the even digits, so you guys can see more clearly. We can see that 1, 3, 1 are the odd digits, and then 2, 2 are the even digits. So we need to find the difference between the sum of the blue arrows and the red arrows. For blue arrows, just 2 plus 2 equal 4. And then for the red arrows, it's 1 plus 3 plus 1 equals 5. And now we need to find the difference between these two sums, which is just 5 minus 4 equals 1. Now we got the difference between the odd and even digits when 1 divided by 11 equals 0 with a remainder of 1. So the number 12,321 divided by 11 have a remainder of 1. So now we're talking about also like following like the kind of the same way going on with 11, which is 101. They were basically the same, but like instead of like the odd and even digits, so odd and even digit, basically we're just cutting one digits to a group. But 101, if you want to see, we need to cut 2 digits at a time. If they were less than 2 digits on the left, so it would just be 1 digit. So let's have an example, because this sounds really confusing. Let's just say 13,456. And so when cutting digits, we're always starting from the right. So we'll see, we still use the red arrows for the odd but not really odd digits, and the arrow for the blue, which is the other group. So the sum of the red will be 1 plus 56 equal 57. And for blue one, it would just be 34 itself. So nothing much to talk about. And now we need to find the difference between it again, so which is 57 minus 34 equals 23. Yeah, and then we need to divide 23 by 101, which is 0 with a remainder of 23. So with this number divided by 101, there will be a remainder of 23. Now let's talk about like compare like the 9 and 11. 9 and 101, which is 99. So it's the same with it, but like still like we're combining them. And so for 9, we're still cutting like each digits and then find the sum of it. And for 99, we're still cutting digits, but 2 digits at a time, and then we're still finding the sum. So it's kind of like combine them together. So if it's like you're on a trial of 101, 1001, you're just finding the difference. And then for 999, 999, you're finding the sum of it. So let's have an example for 99. Let's say 14,567. Remember, we're cutting 2 digits and we're always starting from the right. So this time I use yellow arrows and the blue arrows. And then for the yellow arrows, the sum of it will be 1 plus 67 equals 68. And then for the blue arrows, it will just be 45 itself, because only 2-digit number. Yeah, and now since it's 99, so we need to find the sum of it, which is equal 113. So So 113 divided by 99 equals 1 with a remainder of 14. So when this number divided by 99, it will have a remainder of 14. So just like as I say, 1101, 1001 will be a trial, and 999 will also be another trial. It's going on. It's just repeating the same pattern, like changing the number of digits you're cutting. And now let's talk about some special prime numbers such as 7 and 13. So for 7 and 13, they were not a particular divisible characteristics, but since 7 times 11 times 13 equals 1001, so we could use the characteristics of 1001, which is cutting 3 digits and then finding the difference. But like if you can use it, but like if it's not divisible, when you check it's not divisible by 1001, it doesn't necessarily mean that it's not divisible by 7. But if it's divisible by 1001, means it's 100% divisible by 7, which you need to be careful about it. Or you can just calculate it if you want, because 7 is just a one-digit number, so it's not really hard to do it. And also there are also numbers, like some numbers is not prime number, but when you calculate it, you can use it to combine like 21, which is 3 times 7, to check if you can divisible by 3, and 7, if it is, then it's divisible by 21, same to 28. Also, I forgot, let me mention about 4, 8, 16, 2 for this trial, since 2 just checking the last 1 digit, and 400 is the 4 times 25. So we just need to check the last 2 digits if it is divisible by 4. Then for 1000, since 8 times 125 equals 1000, so we just need to check the last 3 digits. And for also the same for 16, and then Newton power going on, just repeating the same pattern again and again.